Lesson 5-8, absolute value functions. So an absolute value function is a function that contains an absolute value expression. So the expression has to be inside the absolute value symbol. An axis of symmetry is an imaginary line that divides the absolute value function into equal parts and goes through the vertex. So this one's going to be, so if I have the graph's going to look like this, the absolute value, or the axis of symmetry is going to be like this dashed line, vertical line that cuts the graph in half. The vertex is the turning point of an absolute value function. It's the lowest or the highest point of the absolute value function. So in this example, this point right here, the low point would be the vertex. It comes to a point there, it changes directions at that point. Now, if you have a low point, it's because the function is positive. It opens upward. And if you have a high point, the function is negative and it opens downward. So we're going to take a look at some examples here by not only graphing, but also looking at the function itself. So here, the absolute value function formats. There is the parent function. The parent function, everything else is based off of. So if I have f of x equaling the absolute value of x, the vertex is going to be at the origin. Now, if you were to move it to the right or to the left or up or down, that would mean you'd have some transformations. But for this lesson, we're not going to go through transformations. We just want to be able to graph the absolute value function and to be able to identify the vertex. But to give you a little bit some information with the transformations, the equation or the base format of the absolute value function with transformations would be f of x equaling a is your dilation, times the absolute value of x minus h plus your k. Your h and your k is going to be your vertex. So whatever h is and whatever k is, that's where you're going to put your main point, which is the vertex here. But remember, this is x minus and whatever h is. So in this example, if it's x minus 4, the h is actually a positive 4 because the negative, or the minus, is part of the form itself. Now, if it was x minus a negative 4, you're not going to see x minus a negative 4 in the absolute value. It's going to be x plus 4, which means your h is going to be negative. We'll review that at another time, but right now we just want to be able to identify where the vertex is and be able to graph it. So how can we graph? The first thing we want to do is find the axis of symmetry, which is going to be the x value of the vertex. Now, if that is difficult for you to doing that, then all you have to do is just put some numbers in for x and y. Put numbers in for x into the function to find what your y coordinate would be, and then you could start plotting them and you can see where it changes direction. So that's option 2, choose points on each side of the axis of symmetry. So once you find the vertex, the axis of symmetry, you're going to choose a point, put that number in for x to find where your y is going to be. So it's going to be somewhere on that axis of symmetry. Then you're going to choose points on each side of the axis of symmetry, because if you don't do it on both sides, then you're going to miss the other half of the graph. And then you're going to connect the points. So absolute value functions, they're always going to be graphed with a V shape. So now let's take a look at our first example here. Here we're going to graph y equals the absolute value of x minus 2. Now this minus 2 is on the outside of the absolute value, so that is actually our k. So if I were to rewrite this, this would actually be y is equal to the absolute value of x minus 0 minus 2. Here's my h and here's my k. So my vertex is actually at 0, negative 2. So I would have a point at the y-intercept right here. So right now, if I were to draw my axis of symmetry, it would just go straight down through this, which just right through the origin, which is just my y-axis. So now we have a point here at -2, and I need to choose points on each side of it. So I'm going to choose 1. So if I put a 1 in for x, the absolute value of 1 is 1. 1 minus 2 is -1. So I have a point at 1, -1, which would be right here. And because I have a line of symmetry, I can mirror that point. Since it's one step to the right of the axis of symmetry, and go one step to the left of the axis of symmetry, and there's my other point. Or you can put -1 in for x. -1, absolute value of -1 is 1. 1 minus 2 is -1. If I put 2 in there, absolute value of 2 is 2. 2 minus 2 is 0. So I would have a point at 2, 0. That means over here would be at -2, 0. So now I have everything I need, and I can just draw my line here. And there's the graph. The axis of symmetry is a line, and we know that this would be x equaling 0, because it's always the x-coordinate of a vertex. The y-intercept, where does it cross the y-axis? It crosses the y-axis at -2. So the y-intercept and the vertex is actually the same here. The domain is all real. That means I can put any number in for x, and it will give me a y value that will land on the line. The range, it never goes below -2. So we would say y is greater than or equal to a -2. So the lowest point is -2. And this one opens upward. Next, here we want to find the vertex on the axis of symmetry. The axis of symmetry, here since I have an x plus 3, this is really saying x minus a -3. Now if I look at just the h is -3 here. So let me get rid of that. So I know this is at -3. And there's no k, so that means it's at 0. So the axis of symmetry is actually x equaling a -3. So if I go to the coordinate plane and draw my axis of symmetry, the vertex is at -3 and 0. So I can now put a point at -3, 0, which would be right here. Now I can choose a point on each side. So I'm going to choose -2. -2 plus 3 is 1. The absolute value of 1 is 1 times a negative is a -1. So it would be -2, -1. And then I can mirror that one. And then I can just keep doing that one. If I put -1 in there, -1 plus 3 is 2. Absolute value of 2 is 2 times -1 is -2. And then that next one would be -3. And so forth. And I can just keep mirroring those points. So your graph would look like this. The y-intercept, this one would cross it at 0, -3. The domain, it's all real. Now for absolute value functions, the domain is always going to be all real. The range, it never goes above the x-axis. So that means y is less than or equal to 0. And this one, it opens downward. Next, graph y equals absolute value of x minus 2 plus 1, and then identify the following. My h is going to be 2, and my y is 1. So the axis of symmetry is x equaling 2. So if I go to my coordinate plane and draw the axis of symmetry at 2, my point is at 2, 1. So that'd be here. And then I choose points on both sides. So if I choose 1, 1 minus 2 is -1. Absolute value of -1 is 1. 1 plus 1 is 2. So I have a point at 1, 2. That means I'm going to have a point at 3, 2. If I put a 0 in, 0 plus minus 2 is -2. Absolute value of -2 is -2. It is 2. 2 plus 1 is 3. So I have a point at 0, 3. It means the next one would be at 4, 3. I have enough to draw my graph. Now to answer the questions, I got my axis of symmetry, my vertex. The y-intercept is at 0, 3. The domain is all real. The range never goes below 1, so y is greater than or equal to positive 1, and this one opens upward. Next, here there's no number inside with the x, no adding or subtracting, so that's 0. So x is going to equal 0, and the vertex would be 0, and then since I have a minus 2 in the place of the k, it'd be 0, negative 2. So the axis of symmetry would be the y-axis. Okay, plotting our point, 0, negative 2. There's our vertex. And then if I plug numbers in, 1 for x, the absolute value of 1 is 1, times negative 1 is negative 1, minus 2 is negative 3. So 1, negative 3. And then I can mirror that one, which would be negative 1, negative 3. I just need 3 points as a minimum to graph, 1 on each side plus the vertex. The y-intercept is 0, negative 2. The domain is all real. The range is, it doesn't go above negative 2, so it has to be less than or equal to a negative 2. And this one opens downward. You'll notice if there's a negative out in front, it always opens downward. Next, we just want to identify the vertex by graphing. So here, again, if I want to do the h and the k, I know the vertex is going to be at 1, 0. But just to prove it, by graphing it, let's put numbers in for x. If I put a 0 in for x, 0 minus 1 is negative 1. The absolute value of 1 is 1. So I have a point at 0, 1, which would be here. And then if I put a 1 in there, 1 minus 1 is 0. Is absolute value of 0 is 0. So I have a point at 1, 0. And then if I have a point at, if I do negative 1, negative 1 minus 1 is negative 2. Absolute value of negative 2 is 2, so I have 1, 2. If I put a 2 in for x, 2 minus 1 is 1. 1 absolute value of 1 is 1. So we have 2, 1, and that means we're going to have 3, 1. Here we have our graph here at the vertex is going to be 1, 0. Next, identify the vertex for this one. I know the x is 0 because it doesn't go to the right or left, but it goes down 1, so at negative 1. So that would be our vertex, but to prove it, put 0 in for x. Absolute value of 0 is 0, minus 1 is negative 1. Choose a point on each side. Absolute value of 1 is 1. 1 minus 1 is 0. Put negative 1 in there. Absolute value of negative 1 is 1. 1 minus 1 is 0. So this one, all it did was it went down because of this last part where your k is negative 1. Next, identify the vertex here. In order for it to be x plus 1, this is really x minus a negative 1 plus 0. So the vertex is actually negative 1 comma 0. So if I have a point here, if I put 0 in for x, 0 plus 1 is 1. Absolute value of 1 is 1. So I have a point here, and then I can mirror that one. And there's our graph. Now, if you wanted to do this on your calculator, I can show you how to do that on the calculator here very quickly. We just want to go to our y equals, clear what we have here, and hit absolute value. You go to math, go to numbers. It's option 1 where it says ABS, hit 1. And in parentheses, I'm just going to do x plus 1. End parentheses, that ends the absolute value. Now if I hit graph, there's the graph there. If I hit second graph, go to the table feature. I want to look at the y's to see where they start to repeat. You'll see that the y's repeat on each end right here, and the middle number that does not is at -1, 0, which is our vertex. And our last one here. Here, if I go back to my calculator, let's do this one on the calculator. The absolute value of, need to get rid of that. So just the absolute value of x, and then on the outside do +1. If I hit graph, here you can see the whole graph moved upwards. So now I'm going to go back here and do the parent function so you can see how it moved. So if I hit math, go to numbers, number 1. So math, numbers, number 1, and then type in x. Here's the parent function. The bottom one is the parent function. It went up 1. Everything else is the same. So the vertex is, we want to go with line 1. You'll notice that they repeat. Here's a 3, here's a 3, here's a 2, here's a 2. So 0, 1. So that would be our vertex on that one. So that's our lesson on absolute value functions.